Welcome back, ladies and gentlemen, to another lecture lesson from Mr. Kenton, AP Chemistry. We're going through Unit 1. We're in Section 1.4 now, looking at the composition of mixtures. And as you can see, this is going to correspond to our Brown and LeMay textbook and Section 1.2 in the text. Now, it's a real small section, so it's going to be a real short video. So remember, we got to talk about the differences between mixtures versus pure substances. If you think about this is stuff that we've done when you think about classification of matter, right? So mixtures have a variable composition, while pure substances have a uniform or a fixed composition, right? And so, for example, like you can think of a mixture like hydrogen peroxide, for example. When you go to the pharmacy or you go to CVS or something like that and you get hydrogen peroxide, you get hydrogen peroxide, but it's only got a percentage of hydrogen peroxide, right? So like you can get 3% hydrogen peroxide. Or if you think about rubbing alcohol, you can get like 10% rubbing alcohol, you get 30% rubbing alcohol, right? And so your mixtures have this variable composition. There's not always a fixed chemical formula for it. Now, maybe the things that make up the mixture have a fixed chemical formula, but not the actual mixture itself. Whereas if we talk about a pure substance, an element, or a compound, right, hydrogen is always H2, right? It's going to be that. It's not going to change. Or sodium chloride is going to be NaCl. It's not going to change from that particular perspective, right? And so just using that in mind, understanding that mixtures have these variable compositions can help us understand how we can identify if we have an impure mixture or sample of something, right? And so that's where elemental analysis comes in. I mean, we've been looking at the empirical formulas, molecular formulas, percent compositions, and understanding that information can help us identify whether or not a sample that we're dealing with is pure or impure, right? So by knowing the molar mass of elements, the percent composition of each element in a compound can be found, right? And we saw that with our empirical formulas. And based on that information, we can use that to draw conclusions about the sample of a substance if it contains impurities, right? And so you guys probably remember this question. I think the wording of it is actually not helpful. I don't actually think there's an easy way to go about doing this. I think we can, but I think a better question here is it says an impure sample of SO3 contains 40% oxygen. What is the percent of SO3 in the sample? I think the better question is, based on the fact that it's 40% oxygen, what is a likely cause of the impurity in this particular case, right? And so one thing you could do is you could use that elemental analysis to draw a conclusion, right? So it says that it contains 40% oxygen by mass, right? Well, if you look at SO3, if we think about our percent oxygen here, right, that should be percent O, it should be 3 times 16, because that's oxygen, divided by the entire mass of SO3, so 32.07 plus 48, so 80.07, right? So you got 48 divided by 80.07, and that's roughly 60%. So SO3 is supposed to be 60% oxygen by mass, but in our sample, we've only got 40% oxygen by mass. So what that's communicating to us is that there is something, maybe a lot more sulfur or something that's going on that's driving that percentage by mass of oxygen down, right? And so that's really what we want to be able to do. And if you remember, you were given questions like this where you were given something and asked, okay, what would be the source of the impurity? What is going to cause this particular impurity to show up and have these different percentages by mass, okay? And so that's pretty much what I want you guys to be able to gather from this particular section is understanding how we can use percent composition to help us to determine whether or not a sample is pure or not, and then be able to make conclusions about how that sample became impure. Does it have a greater percentage of one element or a lower percentage of another, and what the implications for that are. So thanks for tuning in, and I'm looking forward to sharing with you guys next. We're about to move into electron configuration. It's going to be a fun time.